Right. I'm Vivian Mushahwar. I am the principal investigator and the director of the lab that we're in today. This is the Human Rehabilitation Engineering Lab and the SCITCS FES Research Facility at the University of Alberta. We have several sections in this lab to do work that is, in general, focused on developing rehabilitation interventions to improve function after spinal cord injury, head trauma, or stroke. And the section that we're here specifically seeing in this view is what we call the SCITCS FES Research Facility, in fact. This is a section that is equipped, as you could see, with Ergi's FES-driven bicycles, arm cranks and bicycles connected together, and FES rowing machines. Now, the goal of this section is not just to provide exercise. In fact, that is not what we go after in this lab. What we're after, in fact, is to see if we can use electrical stimulation as a method to re-educate the spinal cord in regaining some of the functions that it used to have before a spinal cord injury. And a focus of people that we'd like to attract to this section of the lab is people with incomplete spinal cord injury, as well as people with stroke in the future. But our focus right now is on people with incomplete spinal cord injury. The main goal here, the main idea, is that the spinal cord is usually used to doing rhythmic type of movements. So walking is a rhythmic movement. So can we re-educate the spinal cord to perform walking-like movements, but by training it on a bicycle? And then, should we only be focusing on the legs and just getting the legs cycling, or should we get the arms and the legs cycling at the same time? We think that if we can get the arms and the legs to cycle at the same time, we're actually better mimicking the way we normally walk. Imagine running without moving your arms. It doesn't happen. We usually walk and swing our arms at the same time. So perhaps if we use electrical stimulation with, for the arms and the legs to perform those rhythmic, coordinated kind of movements, we re-educate the spinal cord to communicate, have parts that control the legs, communicate with arms or with parts that control the arms, and communicate in a meaningful, purposeful motion. Now the question then becomes, do we only care about rhythmic movements of the arms, or can we also use arms in a setup over here that is related to FES rowing? So the first setup that we have over here is an FES rowing machine where we could activate the arms and the legs at the same time, but instead of in a cycling fashion, it's more into pull-push fashion, as you see over here. And the question now is that how would the spinal cord respond to this kind of training relative to the other training mechanisms or training paradigms that we have? Okay. The research process for this particular research project involves a few steps, but they're very simple steps. The first step is to contact us and let us know that you are interested in participating in this project. One of the criteria that we need for this project is individuals with incomplete spinal cord injury. So if the injury is complete, if it's the ASIA A, then we probably will not be able to enroll you in this one particular project. If the injury is incomplete, regardless of the level of the injury, we will be able to take you on. Once we do this initial screening, we would require the participants or the volunteers to come to the lab so that we are able to do some electrical stimulation testing, make sure that the muscles that we're interested in activating do have their nerve supply still available, and that the person is able to accept the electrical stimulation without undue distress. So if, for example, they do not react, they don't have a serious sensory reaction, the stimulation is not painful, nor is it too exhausting to the individual. Another thing that we look at is what we call dyssynergia, autonomic dyssynergia, so we make sure that the electrical stimulation does not cause changes in blood pressure or heart rate. Once we pass these criteria through that screening in the lab, then we will enroll the person in one of three groups. a group that does leg cycling only, a group that does arm and leg cycling, or a group that does arm and leg FES rowing. And then we go through the training program. The training program lasts for up to 3 months, and we would like to have people come in a minimum of 3 times a week for 1 hour each time. If this is acceptable and that fits the schedule of the people participating in this study, then we are ready to go. What are the expectations of this research project? Well, one thing that we expect that everyone would benefit from is an increase in muscle mass, improvement in cardiovascular health. We expect that all the participants will be able to gain this. However, the main outcome of our research is to see if we can improve walking after this training. And we believe that there probably will be an improvement in all the participants. So we will measure their walking abilities right before we start the training, and then at periods throughout the training, and then the very end of the training. We believe that everyone would improve their walking capabilities. Whether the walking becomes independent walking is a different story, and is something that we are trying to assess at this point, so that we can improve this training perhaps for the next set of volunteers as we learn from this first set of volunteers.